Yes, my name is Kristjan Zachariassen, and I work with research and development at Vonin. And I have a presentation, but when I chose the title, I discovered afterwards that it was not a good title because it's too wide. But we'll try to come over. And Vonin, that's a Faroe company. It's in Faroe Islands and it's in Norway, and it has covered the North Atlantic. And we are providing fishing gear equipment and aquaculture equipment to the start part on the map. And when we are talking about development, I think our focus is on fishing efficiency. I think that's a very important thing to think about. Oil consumption, that's very much up these days. Selectivity, that's also up, more or less, I would say. And in that, perhaps also bottom impact. That's, you can feel that that's an increasing point that we have to be aware of as a trawl manufacturer. And also user friendliness, that the fishing gear you are doing is as easy as possible to work with. And we can start with the oil consumption. When you think about that, you think we can go into materials. We have not worked with lights so far. The design of the trawls, and also to optimize the trawl opening for the species which you have interest in to catch. And when you talk about materials, you can use better materials in the trawl, and you can then use thinner materials, and that will give you less resistance, and then you save some energy. But you always have to have that up against that stronger materials normally are more expensive. But the way is that the materials are going thinner and thinner. The design, there you can put in pelagic trawls and in bottom trawls, there's a big difference in the resistance just to change the design. And we are using computer programs a lot to put trawls in these computer programs, and then we can see how much tension is from the trawl. This is a red. Yes, this is a pelagic trawl, which we test a lot. And we also test bottom trawls in this program. This is a double trawl. And from this program we can also see tension or the weight to the bottom. And that can give us an idea about how much the bottom is affected, or how much tension you put on the bottom when you take the trawl over it. We also make a lot of tests in flumetank. You build models and you test it. We are either in Denmark or in Newfoundland. There you can see a pelagic trawl, and here is a bottom trawl, a normal bottom trawl. And if you talk a bit about the design of the trawls, normally you put it in two parts, the front part and the aft part. And in a pelagic trawl especially, the mesh size and the twine diameter and how open you can make these meshes are affecting the resistance very much. It's also in the bottom trawl, but not as much as in the pelagic trawl. But what we have seen also is that the aft part of the trawl is very important if you will reduce the resistance of the trawl. Here you can see different designs of the aft part of the trawls, and some of these designs are giving much more resistance than some other designs. But then again, you have it up against that the fishing efficiency always have to be as good as it was before. But I think what is coming more and more up, both in pelagic trawls and also in bottom trawls, that is that you are specializing the trawls to the fish species that you want. If you, for example, take a pelagic trawl and you are fishing for some fish species, it can be mackerel, which is up in the surface, very close to the surface. Then you have two choices. You can make a trawl which is specialized for this fish species, or you can have a more or less common trawl or a multi-species trawl. And then you can see you use a lot of energy for nothing, or even worse, you use some energy to catch some fish which you not want to catch. In the Faroe Islands, we have the challenge that the fishermen would not like to fish the herring when they are fishing mackerel. Not too much herring because the prices for the herring are better later on the year. So I think the changes are also both in pelagic and bottom trawl that the trawls are made for the species you are fishing for. And here you can see two designs which we have designed and also sold. This is a specialized trawl for fishing the surface, and this is a normal trawl. And you can see you can perhaps increase the fishing efficiency of the trawl, but you have the trawl where you would like to have the trawl. In the same way, you can talk about bottom trawl. In Faroes, we have that for fishery for monkfish, they like to have a very low trawl. And they have started to use a very low trawl, but very, very wide trawl, instead to use the more common trawl, which is suitable for many species of fish. But also, when you are trying to design trawls, you always are looking for to have the mesh sizes in the trawl, in addition to the thickness of the twine. You'll always like to have the optimal mesh sizes in the trawl. And it's not always very easy, because in some places you need to have small meshes, and in other places you can have bigger meshes. But we have also some cooperation with the Marine Institute in Faroes, Havstovan. We work a bit with water flow in the trawl also, and fish behavior. We use aquadop sonar, aquadop, to measure the water flow. And we have used this for 3 years now, and we can see very interesting results which we can work more on, because we have got some basic knowledge which we can build further on. For example, we tested a bottom trawl. We went out, tested it. You could see the water flow, but we could also see that the water flow was decreasing a lot in a part of the trawl where we didn't like that the flow was decreased. And then we made some changes with the trawl, and could get more water flow. Here you can see a belly, or just in front of the cotton, the trawl with poor water flow. You can see the net is hanging, and the diameter is very little. And the fish is just filling up there, it's not going back to the cotton. And here we just made some small changes. We put some T90 in front of that section and made some changes in cuttings. We got some extra diameter, but you can see we got much better water flow. You can see the fishes need to swim much more. and it's going back to the cotton where it shall go. Yes, it's called Ultra Cross Hot Melted. I don't know what that is, but it's a very strong netting. We do also work a lot with selectivity, and I think all trawl makers are working with selectivity. That's both that is in many fisheries it's mandatory, but it's more and more also start to be more voluntary. For example, in the shrimp fishery, it is mandatory to use sorting grids. In the blue whiting fishery in Icelandic waters and Faroe Islands waters, it's mandatory to use a sorting grid in certain areas. In the cod fishery in Norway, they have to use sorting grids, and I don't know how it's in Iceland. In Faroes, we just use the meshsize in the cod. But it's also voluntary basic that they use some selectivity devices, for example, in the mackerel fishery in the Faroes. Or they started to use it. And when you talk about development, we're also trying to optimize these sorting grids because we think that that's a very important area to work on, because when the fish or the shrimp enter the sorting grid, you have catched the fish, and if this part of the trawl doesn't work very good, then you just leave the fish out again, and that doesn't make very much sense. Just catch all the fish and then let it out again. So we work a lot with design and materials, make them more functional and mainly we work with two types of sorting grids. These are mainly used in the pelagic fishery. It's flexi panels called. They're made in Shetland. It's a grid built by tubes, put in a net section, and outside you have some kites to get some spread in the opening here. This is a grid for the shrimp fishery in Greenland, and so there are some other grids also. In Norway, they use this sort V, is the most common. And here you can see the sorting grid for the blue whiting fishery. These tubes are stretched out by these scallop tubes, and the fish is going through. And the aim is that the head has to go outside here. There's an opening downward. This grid is sorting out downwards. It is mandatory, as I mentioned, the Faroes. It was because of that the catches of said could be a problem. And here we can see in front of the grid, you can see all the small animals that shrimps, a lot of numbers. And enter the grid. And I took this clip with me. You can see the shrimp is entered, and the idea is that they are going as good as they can. And sometimes it could be good to get some help. In some occasions, we can see some seals are entered the grid. And Andreas, he have been made on shrimp trawler on 300 meters, I think it said. 400 meters. But they are helping. They are cleaning the grid for fish. Flatfish are laying on the grid. They like to go out and pick it up, and that's fine. As I mentioned, also there's can be some mandatory. We have this year and last year worked with a sorting grid for mackerel to try to sort out the herring and the small mackerel. And one boat has used this year. And here you can see the grid in action. All this netting, the idea is that the herring shall go out through this netting and the mackerel shall proceed. And also for shrimps, we have a similar solution, but we have worked with it, but it's not used so far. But at that time we started on that project, the shrimp prices for the big shrimps were about 100 kroner, but now they are not so high. And when you're working with trawls, bottom trawls, you need to have some bottom contact, and that can be a challenge. On the one hand, you know that a bottom trawl needs to be on the bottom. But on the other hand, you know that a lot of people and organizations are trying to stop trawl fishery because it's have some effect on the life in the bottom. And we are working on that. Here you can see a rock upper gear.
The black stuff behind that?
Yeah, that's the black stuff behind there. It's from a project degree. It was 5 years ago, I think. And here you can see some tests we made in that project, and we are still making tests at Vonin, and I think all trawl manufacturers which work with bottom trawls are making tests with bottom gear. Because the fisherman wants the trawl to be on bottom all the time.
Is that the plate gear?
Yeah, combined plate and some rolling wheels, bobbins. But as a net manufacturer, we need to be aware of that there is some pressure from the environmental organizations. But also we know that if we have less impact on the environment, it can be both that we have less oil consumption or we have less drag from the bottom. You use less oil and disturb the nature less and saving some money. We are in a project in Canada, a big project, to reduce the impact. Now I come to the user friendliness, and that's perhaps the most important, or one thing you have to be very aware of when you are working with it. You can try many very good things, but if you can't work with them on board on a trawler, not just for 7 days, but for every day in the year, for a shrimp trawler, for example. So the trawls have to be easy to work with, and that can be a challenge to get that to fit into all the other demands. And I think the trawl makers, they're trying to have as few mesh sizes as they can in the trawl, because then they don't need to have so much net material on board, and it's easier to repair. Try not to have so very complex cuttings. Trying to have good materials, but as I mentioned, you're heading up to a loft where the materials is so expensive that you can't use them, especially not where the trawl can be damaged very often. Double net and salvages, bottom trawl. But also, especially for pelagic trawl, it makes them easy to handle in the hauling procedure and the shooting procedure. And here we can see two drawings of trawl, one with a very simple cutting, easy to work with. If the trawl is damaged, there's a few different lengths. And here you can see a more complex drawing, a lot of lengths you have to be aware of, and you are almost sure that you make some mistakes when you repair that trawl on board. So to meet all this, the trawl manufacturer, we need very good relationship with the customer and also with the researchers. And I think at least in the Faroes we have that. For example, we are talking together daily, and we borrow these current meters, these aqueducts from the Havstovan, and we are also running project together. And actually I have worked there for 10 years. That will make it worse. But it's very important, because I think alone you can't make everything. It's impossible to change all things and they will work. But if you have a very good cooperation here and you talk, then you can obtain very much. And also, we are aware of that, for example, the presentation before this with the light fishery, but it's not so easy for us to go so very far away. We always need to be in a step where we can reach all the time. And then I think the trawl factories, they can help the researchers when they have these projects with light fishing, and I think some are thinking about air bubbles I have seen somewhere and things like that. But I don't think that we will run projects like that, but we're happy to be a part of such projects. But we leave it to the scientists to run these projects. Well, thank you very much. And this is what the fishermen like.